Hello students, welcome to Power Tutorials. So today we are going to cover part 3 of Science Class 10 NCERT, that is CBSE board, chemical reactions and equations. So in the previous parts I have discovered about what is chemical reaction, what is chemical equation, word symbol equation, word equation, symbol equation, also how to balance chemical equation, and why we have to do it. We also discussed about change in, okay, these are regarding chemical reactions. These are all covered in part 1 video. And then as I mentioned, first two questions I have explained in the part 1 video, but as I mentioned, the other questions I will discuss once all the chapter is completed in the live session. We'll cover in text as well as the backside questions. Okay, so then I have discussed about part 2. In the part 2 I have discussed how to write symbols for physical states and types of chemical reactions, and we have started types of chemical reactions. Total 5 types we have: combination, decomposition, displacement, double displacement, and redox. So combination and decomposition are been explained in the part 2. So in decomposition we have different types, so those types we will cover in endothermic and exothermic is also covered in part 2. Okay, so those two, part 1 and part 2 links I will also keep in the description, so whoever have a doubt regarding those topics you can check those links. Okay, so let's start with part 3 video now. So today's agenda is decomposition. In the decomposition we have 3 types: thermal, electrolysis and photolytic. We'll cover all these 3, and then we'll cover displacement, double displacement, and then oxidation reduction, and also the daily examples, that is corrosion and transitivity, we'll discuss here. So let's study about first one, which is thermal decomposition. So one decomposition we already discussed in the part 2 video, which is ferrous sulfate on heating gets decomposed into ferric oxide, sulfur dioxide and sulfur trioxide. So here also you can see heat is mentioned. So if any decomposition is happening with the help of heat energy, that is energy in the form of heat, we call it as thermal decomposition. Whereas other two, which are electrolysis and photolysis, the name itself it is saying electrolysis means we are passing current to it, due to which it is happening electrolysis, and second is photolytics, through with the help of light. So we'll cover thermal, few more examples for thermal decomposition. The second example is heating of lead nitrate. So if we heat lead nitrate, also decomposition reaction happens, and this is also heating, so thermal decomposition. So we'll also use different colors and perform the experiment now. We'll use test tube as this color. So what we have to do in the experiment in the school means, you have to take a test tube, with the help of stand you have to fix it. Take lead nitrate into it. We'll use another color. Let's use green. Okay, and then apply flame. As I mentioned, it is thermal decomposition, so with the help of heat decomposition happens. So what happens if you keep lead nitrate in a test tube, and if we heat it, the lead nitrate will get decomposed into lead oxide, nitrogen dioxide and oxygen. Okay, so let's write the same equation. So before this, the marking is important, so we have to mark. I'll use blue color back. So this is test tube, burner, lead nitrate, and this is stand. So most of the cases, make sure to write all the parts in the same part, so that the invigilator, or who, if you want to read also, it will be easy to read the parts at the same point instead of writing one to the other, one sides. Okay, so what happened here, I will write the equation in the next slide. Lead nitrate is PbNO3 twice gives rise to lead oxide is PbO, and then nitrogen dioxide, which is NO2, and then oxygen, which is O2. So this is solid, lead oxide is solid, and the gases, these two are gases, so those will be emptied out. Okay, so let's balance this. Nitrate we have 2, so nitrogen is 2, so here if you keep 2 I'll become nitrogen 2, oxygen 4 plus 2 6, oxygen is 6, that is fine. So this is balanced. Let's check for oxygen 2 4 4 plus 1 5 6 7 7 oxygens are there. Okay, so you have to keep it, you have 6 here, and nitrogens are fine, but oxygen 3 we have here, 1 4 5 6 7. Okay, let's do one thing, let's keep 2 here and let's keep 2 here. Let's check. 6 2 is 12, 4 plus, okay, 2 oxygen, 4 oxygen, 2 plus 4 6. Okay, how many here? 6 2 is 12, so if I keep 6 I will get 12. Let's check. 2 lead is fine, oxygen 3 2 is 6, 6 2 is 12, 2 plus 4 6. Okay, here it is, should be 3 O2 not 6 O2. 2 plus 4 is 6. Now if I keep 3 O2 it will become 6. So 6 plus 6 is 12, and here also it is 12. Now it's a balanced chemical equation. So make sure to cross check when you are writing any balanced chemical equation. So what is happening here? Lead nitrate is getting decomposed to lead oxide, nitrogen dioxide, and the last one is oxygen. So as this is also happening with the help of heat, and this is important, on the arrow you have to write it at heat because it is a thermal decomposition. Okay, we have one more example for thermal decomposition, example 3, which is calcium carbonate. If you heat it, it forms CaO plus CO2. So this is calcium carbonate. So calcium carbonate, if you heat it, what will form? It will form calcium oxide, which is also called as quicklime, plus carbon dioxide. So as I have mentioned, we are supplying heat, so definitely on the arrow we have to keep it as heat. And this is mainly what is the use of it? It is used in cement industries. So if you remember, in combination reaction we also use this same quicklime, and we have used with the help of water, if you combine you will get calcium hydroxide. So this calcium hydroxide we also keep it on the wall and keep it open so that carbon dioxide can act on it. Then again CaCO3 will be found, which is nothing but whitewashing. Okay, so this way if you remember this combination, this reaction, both combination as well as decomposition, you can remember if they ask for 2 marks examples. But this is a best example for decomposition, this one, and the other one is for the lead, just ferrous sulfate solution on heating, it will get decomposed. Okay, now let's see the second type of decomposition, which is electrolysis decomposition or electrolytic decomposition. So what is electrolytic decomposition means? To perform this experiment, I have to take a beaker, okay. So to this beaker I am attaching 2 electrodes. So with the help of graphite I am using, and connecting one graphite using a fixed rod, take it out, same way another rubber cock, another graphite, and these 2 electrodes I am connecting to a current supply of 6 volts battery I am using. If mentioned this way, but it's not like only 6 volts you can use, you can also use 10 volts, doesn't matter, but don't use much higher voltages. Okay, now what I am doing, I will inverting, okay, I will pouring a water inside this, I will use another color, and using 2 test tube I am keeping it in a inverted position. Okay, test tube I will change to another color again, let's use this one. So these are two test tubes in inverted position. So what will happen if you keep any test tube in container, a bottle containing water? It will just move up little bit. So the water now little rises up. Okay. Here let's assume it is rising up. I'll remove this part of water. So now you can understand that the water is getting rising. Okay, so now if we supply current to it, what will happen is inside the water we have two gases which are hydrogen and oxygen. So those two will get decomposed. Yes, decomposed. And here in the negative side you will find oxygen gas, and in the positive side, which is anode end, you will find hydrogen gas. So why? Because oxygen is negatively charged, so it will get, wait, sorry, this I wrote it is wrong. This is positive, this is negative. Okay, so positive is anode, so at anode oxygen gas will be emitted and negative hydrogen will be emitted. Why? Because oxygen is negatively charged, it will attract to the positive anode, and hydrogen is positively charged, it will attract to the negative anode. Okay, negative anode, it's not anode, it is called cathode. So this is cathode, where hydrogen gas is emitted, where oxygen gas is emitted, we call it as anode. Okay, so now if we supply electricity, as I told you, at this part oxygen gas will be created and this part hydrogen gas will be created. So what is the equation now? It is H2O giving rise to hydrogen and oxygen. Let's balance this. Hydrogen 2 2, okay, oxygen 1, here 2. So let's keep 2 now, and let's also keep 2 here, so that both will be emitted. So hydrogen, water in terms of liquid you're getting, when gases, these are in the form of G's. Okay, so with the help of current, I have to mention in the on the arrow that with the help of current, water molecule that is in liquid form, it is getting converted into hydrogen and oxygen which are in gaseous form. Okay, so this is an example for electrolytic decomposition, where with the help of current I am displacing a liquid into two gaseous forms. So let's see the third type of third type of decomposition, which is photolytic decomposition. So what is photolytic decomposition means? The name itself is saying the energy here, it is in the form of sunlight, in form of light, but our experiments it is using sunlight. Energy in form of light is called photolytic, and here in the example we are using sunlight. So what is experiment how to perform is, so take one china dish, like a small cup like thing. So on it let's keep silver chloride. Not this color, it will be in brown color, but I'm using here. So if you give silver chloride here and make it yellow, so that sunlight will fall on it. So what happens if sunlight falls on silver chloride means, whatever the silver is there, sorry, chlorine is there, it will get converted into chlorine gas and only the silver will get on the plate. Okay, so the equation is simple. AgCl gets decomposed into Ag and Cl2. So here chlorine, so let's balance this 2Ag, 2Ag. So same reaction will also applicable for bromine as well. So 2AgBr, if I keep to sunlight or any light, what will happen? It will get decomposed into 2Ag and Br2 as a gas. Chlorine, these are gases, these are solids. So what is photolytic example means, AgCl or Ag silver bromide get decomposed into silver and chlorine or silver and bromine. So what is application of this photolytic decomposition means, it is used in black and white photography. Okay, this is also important. Where what is application of AgCl to Ag and silver is, it is used in black and white photography. Okay, so in detail if you want, you can also check in various websites. what is black and white photography, they will explain in detail, but right now just understand that the application of photolytic decomposition is used in black and white photography. Okay, in this way the second type, which is decomposition, is done. So now we are moving to the third type of chemical reaction, which is displacement. So how to understand displacement means, just remember as a shortcut I am saying, stronger metal removes metal, I can say weaker metal, from its solution. This is a general form, but the exact displacement means, if a strong metal displaces weaker metal from its solution, is called displacement. Okay, this is a definition, but just remember, instead of displacement it is called something like a removal. So what is the general best example for displacement? We'll see now. Okay, so we'll discuss same with the help of what is there in redshift, and then we'll also cover few other equations. So what is the experiment they have conducted is, they have used copper sulfate and ferrous nail. So they will perform the same experiment. Let's take, okay, this color. So what is the experiment is, they have taken a small kind of beaker, or else a big test tube also is fine. Okay, so inside this test tube draws copper sulfate. Okay, this is also blue color, so simply I'm drawing copper sulfate, CuSO4. This is a test tube, and to this I am attaching to a stand. Now I am using a thread and keeping nail of iron. Okay, I'll change the color. Let's use this color. Okay, so these are iron nails. Nails mean everything everyone knows, which you keep in walls to hang anything. Okay, so using with the help of thread I am dipping 2 iron nails inside copper sulfate solution. So what will happen means, this iron will react with this copper sulfate. Iron is more reactive than copper. So as per the definition what I have told you, the stronger one will replace or removes the weaker from its solution. So the equation is simple. So ferrous plus copper sulfate, if both are reacted, what I have told you, ferrous will remove copper from its solution and copper will be emitted out. So we'll get ferrous sulfate plus copper. Why? Because ferrous is more reactive than copper. Okay, so if you want to remember in terms of like animated or cartoon type of picture, just remember that we have a core. So inside this core we have a weak person. So now what we have means, we have one stronger person, say something like a gunda. So he is a rowdy kind of thing. So he is simply moving in a car. But what will happen if strong person comes and attacks him? The weak person definitely will run away from its solution part, and the strong person is taking that core. So same thing here. So okay, let's take in positive way. Just understand that he is police and he is the robber who has stolen the car from someone. Okay, now he is using it. But what will the police will do? He will go and hit him so that he will be out, and he will take this car and he will give this car to the respective owner. Now he is out. Same way here also what is happening? The stronger one, that is a ferrous is strong here. This strong person is removing the weaker metal from its sulfate or the metal solution, so that the weaker metal will be coming out and the strong metal will be combined with the solution. So with respect to names, I can say this is ferrous or iron, this is copper sulfate, whereas this is ferrous sulfate, and we have copper. Okay, this is the example for displacement reaction. With help of small other examples also you can write by your own, like simply if I have copper, okay, it will not displace. Let's take higher metals, like if I take magnesium plus HCl, what will happen means MgCl2 will be formed and hydrogen gas will be emitted out. Okay, why? Because magnesium is more reactive than hydrogen. So what will happen? Magnesium will take the place of hydrogen and it will be emitted out, whereas magnesium valence is 2, so it's just it is MgCl2. So let's balance this. If we keep here, yes, now it is balanced chemical equation. Okay, so simple. So here you have to write magnesium is more reactive than hydrogen. Okay, so this way hydrogen is emitting out, but hydrogen is not been metal, it will be in gas state, so it is gas, and this is liquid, so magnesium is solid. Okay, this is one of the example where higher more reactive metal is replacing the less reactive metal and it is taking its place. So this is displacement. So you can also guess what is double displacement, which is nothing but the fourth type of chemical reaction, double displacement. So what is double displacement? Means displacement is happening twice. So both metals exchange their positions. So one of the best example they give in all the textbooks is Na2SO4 plus BaCl2, which is barium chloride, gives rise to NaCl and BaSO4, which is barium sulfate. So what is happening here? Sodium is more reactive than barium. So barium will be replaced with sodium and barium will take the place of sodium. So it is sodium sulfate if reacted with barium chloride. So what will be formed? Sodium chloride and barium sulfate. Okay, so let's balance this Na2Cl2. Okay, now it's a balanced chemical equation where sodium is replacing the place of barium and it is taking its place, whereas one of the important for this reaction is BaSO4 is a precipitate. Okay, it is a solid and it is a precipitate, thus we have to represent it as down arrow. They can ask you in the question exam also, give an example for precipitate reaction, then you have to give this reaction. Okay, so where we have BaSO4 which is getting formed, it is in the form of precipitate. Okay, NaCl is a liquid, BaCl is also liquid, and Na2SO4 is solid. Sodium sulfate, yes, this is also liquid only. I'm sorry, sodium sulfate is a solid. Okay, so if you add sodium sulfate to barium chloride solution, sodium chloride solution will be formed and we will form one BaSO4 as a precipitate in that same test tube. Okay, so this is example for double displacement. Let's see the other one. The last reaction for types of reactions, which is oxidation and reduction. Okay, so as per the definition, what is oxidation means? If oxygen is getting added to any metal, then it is called oxidation. Same way, if oxygen is getting removed, is called reduction. Okay, same way this definition also applies for hydrogen case. Like if hydrogen is getting added, we call it as reduction. And the same thing, if hydrogen is getting removed, it is called oxidation. So you have to remember both the cases, hydrogen and as well as for oxygen. But if you want to know in why exactly why we have both oxygen and hydrogen, so because oxidation means you are giving negative charge to an element and reduction means you are giving positive charge to an element. So oxygen is a negative charge, if you are removing means it will getting positive charge, so that's why it is reduction, whereas oxidation is giving negative charge to it. So oxygen is a negative charge, if you are giving negative charge it is oxidation, if you are giving positive charge it is reduction. Just remember, in that way it will be much useful for your next classes as well. Okay, if you are giving negative charge, oxygen is negative charge. If you are giving oxygen, oxidation. If you are removing oxygen, reduction. If you are giving hydrogen, which is positive charge, so reduction. If you are removing oxygen, which is negative charge, so I'll write it simple. This definition you have to write in your exam, but for your next standards as well, I'm giving a shortcut trick. If positive is getting added, if positive is added, then it is reduction. If negative is getting added, it is oxidation. So you can also think for the opposite cases. Okay, oxygen is negative, so that's why it is oxidation. Hydrogen is positive, so that's why it is reduction. Okay, hope you understood the basic definition of oxidation and reduction. So now we'll see an experiment to perform the oxidation and reduction. So what we are performing is we're taking one stand. So below this stand we're keeping a burner. So above it we're using a china dish and adding copper inside it. And if we heat it in the presence of air, it's an open place. Okay, so what will happen if we, okay, I'll write the parts. This is china dish, stand, burner, and this is important, which is copper. So what happens if we heat copper in the presence of oxygen? So it will get oxidized. So simply what I am saying is copper is getting heated in the presence of oxygen to form copper oxide. So let's balance this. 2CO2. Yes, this is a balanced chemical equation where copper in the presence of oxygen getting converted to copper oxide in the presence of heat. Heat is also important. Okay, so what will happen is which of the copper is present here, the bottom part will get black color. I'll use a black color here. So black copper oxide is black in color. So this way at the surface you can find copper oxide is getting created. Okay, so this CEO which is getting formed, if a hydrogen gas is passed over it, if H2 is passed over CuO, what will happen means CuO will get added with hydrogen. It forms CuOH twice, and sorry, it is removing it. So will get removed, oxygen will get removed, and H2O will be created, which is water. So here this in this reaction what is happening, oxygen is getting removed. Okay, so you can see this part, hydrogen is getting removed from copper, sorry, oxygen is getting removed from copper. That's why we call this reaction as reduction. Whereas in the other case, here oxygen is getting added, that's why we call this reaction as oxidation. Okay, one more thing, if any reaction when oxidation is happening, definitely there are cases where most of, at least one will get reduced. So I'll write the second equation again, which is CuO plus H2 gives rise to Cu plus H2. If you observe clearly, copper is losing an oxygen, which is reduction. What about H2 here? H2 is gaining an oxygen, so this is nothing but oxidation. So in the same reaction both are happening, so that's why we call this type of reactions as redox. Redox means combination of both oxidation as well as reduction. So we have one important point here, oxidizing agent and reducing agent. Oxidizing agent, reducing agent. So what is oxidizing agent? Oxidizing agent is the one which is helping any metal to get oxidized, helping other to get oxidized. Whereas reducing agent is the one which is helping other to get reduced. So in this reaction, hydrogen is helping copper oxide to get reduced. So reducing agent is nothing but here hydrogen. Okay, and copper oxide is helping hydrogen to get oxidized. So it is oxidizing agent here is CuO. So which is getting reduced? It is CuO. Which is getting oxidized is hydrogen. But what is the agent which is helping copper oxide to get reduced? Hydrogen. So H2 is reducing agent. CuO is oxidizing agent. But which are getting reduced? Which are getting oxidized? Which is getting reduced? Copper oxide is getting reduced to copper. Hydrogen is getting oxidized to water. And repeating this slide again, here two things we need to important. Agents are different and the ones which are getting oxidized or reduced are different. CuO is getting reduced to copper, so copper oxide is the one which is getting reduced, which is helping to make it reduction, hydrogen. So hydrogen is a reducing agent, and which is helping hydrogen to get oxidized, copper oxide. Copper oxide is the oxidizing agent. Okay, this is the main difference for oxidation and reduction as well as reducing agents and oxidizing agents. Okay, let's see the last topic from this chapter, which is daily examples for oxidation, which are corrosion and transitivity. So what is corrosion means? So I think you might have seen in the daily examples, like if we keep iron mesh outside in our garden, after some days we can find that if it is kept open and moisture everything is falling on it, you can find the same iron mesh which is there in the garden will be coated with brown color kind of texture. Something like this you can find. Some brown color kind of texture will be formed on that iron grails or iron mesh. So what is this brown color? It is nothing but iron oxide. Okay, so iron is getting oxidized with the help of, in the presence of air or in the presence of water, whatever it is. So it will get oxidized to Fe2O3, which is iron oxide or ferric oxide. Okay, so this is nothing but one of the example, and the second example which I will provide is, so what I hope everyone knows what is silver ornaments. So if the silver ornaments, for example like a bangle, okay, I don't think most will use, okay, I can say yes, few uses silver bangles as bangles like a kadiyam, we call it in generally in Hindi also I think it is similar way. So which they use in legs as well as in hands also they will wear it, this type of things. So sometimes this silver color, instead of shiny white color, it will move to some light black, or I can say black, not completely black, but still it will not be this much of shiny. So what is happening here? The silver ornament which is wearing, it is getting connected with outside atmosphere where we have oxygen in the presence of moisture and H2O which is in atmospheric water vapor. So in the oxygen from these two will get attacked on this silver ornament, and this silver ornament will get corroded. Not, it will not completely spoil, but still yes, there is at least 0.1 percentage of silver is getting changed and it is getting corroded to black color. I think another example is the easy one, which is copper bottle. I hope everyone knows what is a copper bottle. So copper bottle, if you keep like wet for a longer time, if you keep it outside, it is for 5 or 6 days, what will happen to the same copper bottle? You can also find some greenish texture will be appeared. Some green color texture will be found mostly on the cap and the lidge point, and even in the bottom part also you can find some black color kind of thing. So what is here? Copper is also getting oxidized. It's not only due to oxygen. Here sulfur is also acting on copper. It is formed copper sulfide, which is green in color. If you find the copper is getting black in color, then it is copper oxide. Always remember, copper oxide is black in color, whereas copper sulfide is green in color. Okay, if you find green on the copper bottle, then it is copper sulfide. If you find black on the copper bottle, it is copper oxide. Okay, silver, if you get oxidized, it will convert into black color. Okay, this is one of the example where metals get corroded with the help of oxygen in the presence of atmosphere. Metals change color or simply get rusted because of oxygen present in water or water vapor or even gas. Oxygen in air, moisture, water vapor. What is happening? This process is nothing but getting corroded. Okay, so mostly for vehicles also, what they will use to prevent this, what they will use: oiling, painting. Mostly this paint should contain zinc. Zinc will avoid the rusting of any metals. Okay, and also galvanizing, we also call this process galvanizing. So galvanizing a process where we will apply some coating on metal so that it will not get corroded. Okay, and then the second type of which you use in daily, which you see in daily life, is rancidity. So what is rancidity means? If you keep any food box open, so the food should contain some fats or oils in it, such type of food. Okay, food containing oil and water, oil and fat. what will happen if you keep longer time for at least for 2 days also? Its smell and taste changes. Its smell and taste changes. So why it is changing? Because it is oxygen which is present in air is getting acted on the food. Oxygen reacts with it and gets rancid. Rancid means change of food color as well as taste or smell as well. Okay, so what is rancid means? If we kept food which is containing fats and oils for longer time outside, the oxygen or the other gases which are present in the atmosphere makes that food oxidized, which is getting making it rancid. Okay, rancid is the one which is containing, like which is getting changed, and which are getting changed. What are the properties? The smell and taste gets changed. So you might be wondering, I think everyone knows what is a Lay's packet or Kurkure chips or any chips packet. You might be seeing that they will fill that chips packets with some air. Okay, so I think Lay's packet is the best example. So why they filled with air? What is that air inside? The air inside is nothing but nitrogen. So why they will fill this? Because which are the chips packet which we have, so those chips packet are deeply fried, so definitely oil is there inside it. Okay, so what I have told before, if a oily substance is kept outside for a long time, it will get oxidized and will get the smell and change. But the chips packet, if we eat it, I think at least for 2 to 3 months the expiry date will be there and it will not get spoiled. Why? Because inside that chips packet they are keeping nitrogen. So why nitrogen? Nitrogen is kind of a inert gas which will not allow the outside atmospheric gases to act on the chips. It can be oxygen, sulfur or anything. The nitrogen which is present inside it, it will be acting as a protective layer so that the outside gases will not get, I mean it's not like 100% it will not stop it, but still at least 99.9% it will stop, so that the outside gases will not enter inside the chips and the taste will not get changed. Okay, this is this is important. One of the best example to understand how to avoid rancidity is either use airtight containers and also can use gases like nitrogen to make food more for longer time, or to make food fresh or keep food fresh for long time. Okay, so in this way complete chapter has been done, but yes, we have still one more part. I will keep that part in the live video where I will discuss all the in-text questions and the example or the exercise questions in detail, and we will explain in detail. So whoever have watched till here, I hope you should have liked this video. So if you like this video, please do like, please do subscribe, and also enable notifications so that once if I keep the live video, everyone should get notifications for this. And as I mentioned, in the next video questions will be discussed, and I will make sure mostly 99% I will try to discuss these questions in a live session. Okay, so this live session, if I am planning, I will plan after 7, mostly 7, 8 or 9 p.m. Among these 3 timings, I will keep a live session where I will discuss all the questions in detail. Okay, so all the theory part from this chapter is been done. So let's meet with another video. I will discuss about live questions, live video where I will discuss all the questions on it. So thanks for watching.